everyone, welcome back to my channel. My name is Soumya and I am a DevOps engineer. I have been creating a series of lab on Google Cloud. In today's video, I will show how you can deploy a web application to Google's Kubernetes engine. So first we will take a simple web application and then we will package this web application inside the Docker image. So this is a flow which we will be following in today's video. We will containerize this web application in a Docker image. Then we'll upload this Docker image into an artifact registry. Later we will deploy this on a GKE cluster. Then we will autoscale this application using an autoscale option. Finally, we will make this sample app available on the internet. So this is a complete flow which we will be following in today's video. So let's get started with the lab. So before starting, you need to enable a few APIs for this. Since we will be using an artifact registry to store our Docker image, we need to enable the artifact registry API. So let's go to API page. Click on API and services. Under library, type artifact registry. And you need to enable this artifact registry API. So this API is already enabled. If you have not enabled this API, then you will get an option to enable API. So click on enable API and enable this API. Next, we need to enable Google Kubernetes engine API as well. Since we will be deploying the application to cluster, we need this API. So search for that. So you need to enable this Kubernetes engine API. Click on this API and click on enable. So this will enable the API. So this API is used to build and manage the container-based application. So you have to enable this API. Let's go back to Cloud Console. Since in this lab we will be using the Cloud Shell, you need to activate the Google Cloud Shell. So here in the Google Cloud Console, you can see there is an option. So click on this and activate the Cloud Shell. Now Cloud Shell is activated. Since we will be storing our image in the artifact registry and deploy it from the artifact registry, we need to create a repository. Before creating a repository, we need to set some environment variables here. So first let's set project ID. You can get the project ID from the dashboard. So under project info, you can get your project ID. Just copy this and go back to your Cloud Shell. So here set the project ID environment variable. And you can cross verify if the project ID is set properly by running echo $project ID. So this is my project ID. So next we need to set this project ID for the Cloud CLI. So to do that, you need to execute a command cloud config set project ID. So now it's updated. Next you need to create a repository. So you will be running gcloud artifacts repositories create and you will provide your repository name here. So this is the repository name my-repo, and the repository format you will give it as Docker, and the location you will specify the location where this repository has to be created, and will provide a description for this repository. So you can execute this. And if you want to check the locations, you can also run gcloud artifacts locations list. This will provide the location list. You can choose any location you want out of this. So this is how you find the location details. So let me execute this command. Click on enter. So now the repository is created. Next we need to build the container image. So here we will deploy a sample web application called Hello App. It's a web server written in Go that responds to all requests with the message Hello World on port 8080. Before we deploy this application to GKE Cluster, we have to package this application as a Docker image. So in order to build a Docker image, we need a source code on the Docker file. Source code contains your application code, whereas a Docker file is a file which contains a set of instructions on how the image should be built. So you should have your source code and Docker file in your workspace. I have already downloaded the source code in my workspace. This is my workspace. So inside my workspace, I have my source code, lo-app. So if we cd to this will have a Docker file as well. Get this Docker file. So this is a simple application written using Go language. So here we have provided a set of instruction how this image has to be built. So let's build and tag this Docker image. So before running this command, you have to ensure that you are inside the folder where your Docker file is present. So I'm inside the lo-app folder. So using this command, we will build and tag the Docker image for our lo app. So this command will instruct Docker to build the image using the Docker file in the current directory and then save it to the local environment and tag it with a name. The dot represents the current directory. This project ID is a variable which associates the container image with the LO repo. Let's execute this. So this is building our Docker image. Now the image is built. Let's clear the screen. So you can execute Docker images command to verify if the build was successful. So when we execute this command, we can see there is an image created with this specific tag. So whatever we have mentioned in the command, it has taken. Next, we need to add IAM policy bindings to the service account. I have to execute this command gcloud artifacts repositories add IAM policy binding, and you will provide the repository name. And you should also give the location, region where your repository is hosted, and hyphen member. You will provide the service account. This is the project number which you can get it from the dashboard. Under project info, you can get this project number. You will provide that. And then you will add the role. So here you will mention the service account, the role. Here we are providing the artifact registry reader role here. Let's execute this command. Now the IAM policy has been updated for the repository my repo. Next, we need to upload this image to the registry. Before uploading the container image to the registry, we have to configure the Docker CLI tool to authenticate to the artifact registry. So to do that, we have to execute this command gcloud auth configure -docker and the region. You have to provide the region. So let's execute this. Type Y. Now it's updated. Now we have to push the Docker image to the repository. Let's check our Docker image by running the command docker images. So we will be pushing this image using docker push to our artifact registry. So here you can also give it as v1, which indicates it's a version 1. So let's execute this command. So we have successfully pushed our Docker image to artifact registry. Next, we need to create a GKE cluster. So GKE is nothing but Google Kubernetes engine, which consists of a pool of VM instances running Kubernetes. Let's first set the compute region by running the command gcloud config set compute region and the region name. Execute this command. Once it is done, you need to create a cluster. Type gcloud container clusters create -auto and the cluster name. So here I am giving app-cluster as my cluster name. Execute this command. So this will create your cluster. This will take some time to create a cluster. So now my cluster is created in the location US West 1, and it is having 3 nodes which are in running state. So now we are ready to deploy our Docker image to the cluster. So in Kubernetes, applications are represented as pods, and it holds one or more containers in it. And we deploy these pods as a set of replicas. Next, we will create a Kubernetes deployment to run our application on this cluster. And this deployment will have replicas, which are nothing but pods. One deployment pod contains only one container. In order to deploy our application to this cluster, first we need to connect to the cluster. To perform any operation on the cluster, you first have to connect to the cluster. So you can connect to the cluster by running the command gcloud container clusters get-credentials and the cluster name. So I have created my cluster as app-cluster. So I'll be providing that cluster name here followed by the region name. So let's execute this command. From the output, you can see there is a kubeconfig entry generated for app-cluster. Now we need to create a deployment. create a deployment. So you need to execute kubectl create deployment and the name for that followed by the image name. So let's execute this command. When you execute this kubectl get deployments, you can see there is a deployment by the name hello-app. So this is the one which we had created just now. So let's describe this deployment followed by the deployment name. So this is a deployment which is created in a default namespace, contains only one replica, and you can see the pod template. So here you can see the pod specification here. Now let's set the deployment replica to 3. So there is only one replica set here. So let's update it to 3. Executing the command kubectl scale deployment followed by the deployment name. So here you will provide -- replicas equals to 3. So you are scaling your replica set to 3. So run this command. Now you can see it is scaled. So when we execute this kubectl get deployments, here you can see under ready state it is showing 3 out of 1. So it is getting scaled. Let's describe the deployment again by running kubectl describe deployment. Now you can see under replicas it got updated to 3. Now we need to create an autoscaler for these deployments. So let's do that. So here we are creating a horizontal pod autoscaler. So when the CPU percentage reaches 80, the minimum pod it can have is 1 and the maximum pod it can have is 5. So this is the min and max we are setting to our deployment. Whenever CPU percentage is equal to 80, it has to autoscale based on these conditions. So let's execute this command. Now we have created a pod autoscaler. Now let's check if the pods got created by running the command kubectl get pods. So here you can see there are 3 pods. 2 are in running state and 1 is in pending state. So it might take few minutes for the pod to get started. So once the pod is up, the status will change to running. Let's describe one of this pod. Copy one of this pod. So each of these pods will have individual IPs assigned and these can be reached only from inside the cluster. And these pods will have ephemeral IP address and these IP addresses are not static. So whenever a pod gets crashed due to some error, GKE will automatically redeploy the pod assigning a new IP address to that pod. So new IP address gets assigned every time pod gets crashed and a new pod is created. We need a way where we can group these pods together into one static host name and expose this group of pods outside the cluster to the internet. So in order to fix this issue, we can make use of Kubernetes services. So these services will group the pods into one static IP address which are reachable from any pod inside the cluster. So GKE will also assign a DNS host name to that static IP address. And this type of service in GKE is called cluster IP. So this service gets an IP address which are reachable only from inside the cluster. And if you want to expose this service outside the cluster, then you can make use of another type of service called load balancer. So these pods will be reachable through the internet. You can access these pods from the internet. So let's expose our application to the internet using load balancer. We can expose our application to the internet using load balancer by executing the command kubectl expose and the deployment name. Provide a name for the service. So let's give hello app -service and we call this type of service as load balancer, where we will have a common IP address which users can use to access these ports web interface. And the port it will be using 80 and we'll set the target port as 8080. So here -port refers to the port number which is configured on the load balancer. -target -port is the port number which the container is listening to. The container where our application is hosted. So let's execute this command. So now it is exposed. So let's check the details about this service by executing command kubectl get service. There are two services. So yellow hyphen app hyphen service is the one which we had created just now. And the external IP shows still pending. Let's refresh this. So now the external IP is available. Now the pods are exposed to the internet through a Kubernetes service called load balancer. Copy this external IP and open it in a browser. So here you can see there is a hello world message. You can find the host name. Pod is serving the HTTP request to this browser. This is the pod name. This is the pod which is serving our HTTP request. So now we have deployed our application to the cluster. Next, we'll see how we can upgrade our application to a new version and build that application and deploy it to the new Docker image to the cluster again. In GKE, we have a rolling update feature which lets us update a deployment without downtime. So during this rolling update, the cluster will incrementally replace existing pods with the pods containing the Docker image for the new version. During this update, load balancer will ensure that it routes traffic only to the available pods. Let's update our code. So we'll open the editor. So here I will be making some changes. Like here I have updated the version to 2. So it is displaying hello world and the version as 1. I'm just updating this version to 2. So here I have updated this. So I've done with the update. Now let's build and tag this. I will execute docker build to build and tag this new hello app docker image. Let me execute this. So here as you can see I have set the hello app :v2. So this is my new version. So now it's building an image. Now it has successfully built a new docker image. Now let's push this image to the artifact registry. Let's list the image using docker images. So this is a new image which got created and it is having a v2 tag. Now let's push this image to the artifact registry by executing the command docker push followed by the image name. Let's execute this. Next, we need to update our Kubernetes deployment to use this new docker image. So let's do that. So here we will apply a rolling update to our existing deployment. So let's do that by running kubectl set image and deployment followed by the deployment name. So here we are updating our deployment to use the new image which we had created just now. So let's execute this command. So now it has been updated. So we can watch this update by running watch kubectl get pods. So here you can see pods are getting updated. Execute kubectl get services and we'll copy this external IP and open it in a web browser. So now you can see hello world message and the version it is showing it as 2. So now our deployment is referring to the new docker image which we had updated. So that's it, we are done with our lab. So in today's video we learned how to containerize the application and deploy it on a GKE cluster. Also we had seen how to autoscale this deployment and how to make use of rolling update to update our application. I hope this video was helpful. If you found this video helpful, please like and subscribe to my channel and stay up to date with the latest content on Google Cloud. Once again, thank you all for watching.